In this lecture, we're going to talk about brainstorming and problem framing. Now, in the context of extended reality, so AR and VR, this is really something that is dear to me. I'm not really sure that we are getting it right yet. And I think the problem is that we are not always really addressing the problem. Now, in this lecture, we're going to talk about how to find good problems, how to identify a problem. So in this lecture, I'm going to share 7 techniques to help you innovate. The first technique is what I call ideate, implement, inspect, iterate design cycle. Everything starts from an idea, and you really have to ideate. Part of ideation is actually implementing that thing, creating a prototype, and then inspecting it. And not just you as a designer, although that I think that is the first important thing, but you need to test and validate it with users. And then you iterate. I think that through prototyping we can really learn a lot about the actual problem and not just like about our solution. I use ideation for problem framing, and I think that's a really important realization. And so build prototypes to help you understand what the problem really is. Test it with users and then see how they respond. And iterate to improve your understanding of the problem and then also like you grasping for that solution. Next technique. This is more like a how to think about things technique. The killer app problem is that you're trying to find that killer app and you're trying to take on too much. So rather than trying to invent that whole new thing, you can also look at something existing, and all you need to do is be creative and novel in one aspect. Actually, novelty and creativity is not the same thing. So in my opinion, and I always say this to my students, being novel is this idea of being the first at doing something. And that claim is actually never a really strong claim, because you could be the first person to do a really, really bad thing, to have a really, really bad idea. Just because you're the first to talk about it, to write about it, to implement it, doesn't make it a good thing in itself. And so being creative, however, means that you're like looking at something and you're trying to maybe look at it differently or trying to innovate by coming up with one small new thing. And when I talked about design jams, I already talked about this idea of trying to be creative in how you approach the problem and how you execute the methods and how you prototype things, how you implement things. I think that is really cool. That is where you want to be creative. But you don't have to be novel in the whole idea. That's very important. So do this one thing and be disruptive there. The next thing that I want to talk about is really how to frame a problem and how to kind of verify whether you're asking the right questions. So I'm calling this the problem, promise, premise approach. The first question I'm going to ask you about the thing that you're trying to do is, what is the problem tackled by your XR solution? So if there's no problem, then you don't have a solution. So if you have a hard time telling me what the problem is, then you should rethink it. Also, if you think you know what the problem is, what is hard about it? And why is it important? And here I have a little denomination. Why is it important to you? Because this idea of trying to generally say why something is important, I often struggle with this. But I can tell you why some of the research that I'm working on is at least important to me. Because I observe how people struggle, especially students, how students struggle to learn about design. Because in my research on XR and specifically prototyping tools, I have observed how novice designers really struggle with picking up XR concepts and XR technologies. And that's what at least I cared about. And actually, it turns out that this is really a problem, and a lot of people are trying to innovate in that space. Not always having good ideas, but trying to at least innovate in that space. So this agreement on then there is something that is a problem, that is actually an indicator that you're onto something. And so the next question I'm going to ask you, what is the promise of your XR solution? So what are you offering? Where can XR actually help? And what is your value proposition? And so then I want to scrutinize more this idea of why XR. So what is the premise of your XR solution? Really ask yourself critically and carefully, why can XR solve this? And when I say XR, you should actually be a little clearer and say whether augmented reality or virtual reality is the right approach, and then what are your assumptions? Like with every solution, there's always some kind of assumptions. With every design, we make assumptions. Write the intro first. So if you think about an introduction, now I'm talking about a paper, what goes into that? The problem, and that is more like at a general level. The obstacle, now within that problem there is something more specific that you're trying to address. So that is the obstacle, and you should make it crystal clear. What are you talking about in this bigger problem? And then you should introduce the solution. In essence, not like the whole thing. You have the rest of the paper to describe that, but in essence, the 10,000 feet view, what is the solution here? And then comes the hard part, actually articulating your contribution scientifically. So this is where a lot of people struggle. First year PhD students, as well as old experienced professors, really struggle to nail that contribution. A couple of things that I've observed over the years that really annoy me, and so maybe you should try to stay away from those, because I don't think they're really good arguments to make. We are the first to do this. As I said, doesn't mean that this is a good idea, and it's actually not a very strong argument. It's now or never. It's like, please take my paper now. Yeah, I've seen that a lot, and timeliness is something that the scientific community will really know. You know, if you're trying to solve an old problem, I can tell you, we are probably not making the right progress. And this last thing is, this is probably really speaking just to the scientific community, that the fact that you evaluated your solution, that is not a contribution. It's just expected. We are scientists. So obviously we evaluate our solution, so don't claim it as a contribution. Now I'm done with my rant, and we can continue looking at some of the more design-oriented techniques. So in this lecture, I'm going to share 7 techniques to help you innovate. One technique that I really like is this idea of the idea hexagon, introduced by Ramesh Reska in a lot of his motivational talks, and I really like it. And I want to give some examples from the XR space. So the idea hexagon is basically, given an idea X, what is the next good idea from that idea? One way to innovate is to try to extend to the next dimension. Examples he gives is from Flickr, which is images, to YouTube, which is videos. The next way to innovate is to fuse the dissimilar. So X plus Y. And I'm going to have an example here in a second. And then the other way to innovate, which is the one that I really like, is doing the exact opposite of what's been done before. And we're going to see in a second whether you like my XR example here or not. And then comes these, given a hammer, find all the nails, and given a nail, find all the hammers. It's a very popular approach, especially in the technical human-computer interaction design community and research community. This idea of like coming up with a new system and then seeing what this new system or solution, what kinds of problems can it actually solve. So having this idea because you think it's cool, because you think it's creative, because you think we kind of need this, and then see what we can do with it, in my opinion, is actually a very good way to innovate and ideate and do research. But not everybody agrees, so that's fine. The last one that's missing here, and this is actually the one that's done all the time when you look at all the new product announcements, etc., is just adding your favorite adjective. Faster, lighter, better. So these are some examples. And now I'm going to translate this to the XR space. Ta-da, here we go. So taking it to the next dimension, my example here is HoloLens. We've seen a lot of VR things. So for example, Oculus came out, really a cool headset, and that was just virtual reality, and all the AR stuff up to this point was relatively limited, and then the HoloLens came out, and then the HoloLens ported us into augmented reality. But this idea that a CEO walks up on stage and says, this is a 5-year mission, we're trying to figure it out, and we need you to help us figure it out, that to me was really cool, and I think it's the right approach. And now we're going to look up there. So here for the x plus y, so fusion of the dissimilar, my example is the Oculus link. So for this example, I quickly stole, you see from the back, the Oculus, actually an Oculus, the original Oculus, which is tethered. So, right. So then Quest came out, cool. Now we have it all on device, not tethered, standalone, dedicated headset. Pretty cool. And then we're introducing Oculus Link, right? We're going to give you a USB cable. Initially, you had to buy a specific one, a 3.1 USB so C cable. And what it gives you is it turns your, well, standalone dedicated into a tethered device and turns your Oculus, well, Quest into a, hang on, essentially a Rift S, which had just come out. But this idea of turning the Quest into an Oculus Rift S because for this one, you really have to optimize your stuff to get it to work on mobile. And for this one, you kind of can throw whatever because you just buy a better computer if it doesn't work. I think that was quite disruptive, and it was actually quite upsetting that this Quest can now be turned into an Oculus Rift S because people just bought the Rift S, and now this one seems to be the one that Oculus is pushing forward, which, well, we'll see where that goes. And now we're going to jump over here. So cardboard, doing exactly the opposite. So the example that I have here is this kind of plastic version of cardboard, but it's still cardboard, okay? This idea of just doing something like this, a device wrapper, or actually giving you cardboard and putting that on your face and putting your phone inside. Well, that was like the opposite from everything else we had explored at the time. So if you have a hammer, like a smartphone, what are all the things, all the nails you can hit with it? And AR and VR are actually things you can hit with it. Well, because we have a hammer and turning this into an AR or VR display just by wrapping something around it, I thought this was pretty cool. Now, my other example is WebXR down here. So, given a nail, find all the hammers. So let's say if we now do AR and VR, what are all the hammers that could benefit from it? And the web is a hammer that gives access as a platform to a lot of different content. And so bringing AR, VR into the web and empowering the web is just going to take it to the next level. And I think that's why I put WebXR here as an example. And finally, coming back to the Oculus Quest, well, here the idea with the Oculus Quest was just like, okay, we've always had it somehow tethered, and initially the first VR headsets were like really heavy and had to be mounted. So the one adjective maybe to be associated with the headset is mobile and portable and pervasive if you want. So now I want to jump gears a little bit and look more at innovating in interaction design. So the object control design matrix works as follows. So you're putting out a 10 by 10. I don't actually draw a 10 by 10 matrix here, but the idea is you do a 10 by 10 matrix, and then you're thinking about winter and cold, and then you're putting down all the objects you associate with winter, like snowshoes, gloves, hats, boots, ice scraper. So you're putting those here in the rows, and then in the columns, you're putting all kinds of controls that you can imagine, like slider, voice, pressure control, squeeze, shake, dial, whatever comes to mind. And then you're looking at the combinations of these, and you're sketching out, in each of these little quadrants, you're sketching out all the different little funny combinations that you can come up with, like an ice scraper that can be shaken. Now that would be an interesting device. Now we have a combination of objects that we can control in funny ways. And if you sketch those ideas out, this is really an activity you should do in class. I've done this in a lot of interaction design classes. It's actually quite fun. This idea of pushing it out quickly, like doing really a 10 by 10 matrix, like 100 of these ideas, pushes you to be quick. Sketch them out quickly. Ideate quickly. Don't criticize. Don't spend too much time on shaping this perfect idea. No. Just go about it. Try out all these different combinations. That is really cool. Like going all the way through, line by line, diagonally, And I think that is why it's really a valuable technique. It will not always work. Like, it works really well for like warming up brainstorming. So translating this directly to coming up with innovative XR interface and interaction design ideas, probably not going to work so well. But as a warm-up in a class or in a workshop, I think this is actually really helpful. One last thing that I want to share here is the threshold and seeding considerations in tool design. Now, this is something that comes from a paper from 2000 by Brad Myers and colleagues on the past, present, and future of user interface software tools. And I think it's a really cool way to look at tool design. Now, whether you have a new tool, now this could be a user interface design tool or some kind of tool that helps you solve a problem. Let's just call it a tool. And then you look at the whole design space of all the things you could do in XR. And then there is your tool. And then your tool is defined by a threshold. Now that is the barrier of entry that you have to overcome in order to use this tool. So basically all the stuff you have to learn to use the tool. And then the ceiling, which is all the things you can do with this tool but no more. It's like the upper bounds. It's like, that's it. All right? Learn all this to get in here, use the tool, and then all you can do with the tool is here. And then there could be so many other things for which you probably need a different tool or some combination of tools. And now that is an interesting consideration given that there's so many different kinds of tools out there, especially all these kinds of prototyping tools that essentially all do the same. But it actually allows you to compare some of the solutions out there, some of the tools out there. And I think it's a really good way of examining whether the effort that you have to put in learning something justifies the kinds of things you can do with it, so the ceiling that you will reach. Now, one of the really popular tools out there in the AR/VR space is Unity. Unity has actually quite a high threshold, like a really high learning curve. Okay, depending on your background, you may have an easier time. But the first time I opened up Unity, I was overwhelmed. But the cool thing about Unity is once you have crossed the threshold, you're in this land. And you can start to learn all the things you can do with Unity. And then I would say I wasn't really sure where to put this ceiling. The ceiling is probably relatively high, but nobody knows the whole design space of XR. And I'm not sure whether I can do everything in XR. Now, in my research, I really try to have a much lower threshold. So I really want more people to be able to pick this tool up or my tools up more quickly. And I'll do a trade-off because obviously I can really not reach the same ceiling as Unity. And I don't even have to because I'm not even trying to replace Unity. Unity has its place in the AR/VR space. And my tools are just helping more people transition into tools like Unity, so empowering more designers. And that is really the idea of my research. So for me, it's okay to make that trade-off. And so basically the ceiling is lower of my tools, but that's fine. But there are also lots of little problems in the design space for which Unity isn't really a good solution because it has so much overhead. You really have to learn so much and then solve that thing. No, you just use a different tool. And so that's why this graphic is probably also useful because there are lots of prototyping tools out there similar to mine, although my emphasis has been on physical to digital transition, which I don't think a lot of tools do very well. And so that's my claim here, okay? Just saying, as a researcher, and that's fine. It's been peer-reviewed, so I can say that. Now, this is an interesting area here. So there is this overlap between some of the things you can do with my tools and some of the things you can do with Unity. And then that's probably is the same thing for a lot of tools out there. You can use a lot of tools to do the same things. Now, obviously, we're not trying to be like Unity. I would never try to do that. So I don't want it. My goal is not to be congruent, to actually be like Unity. No, you don't want to be like that tool. You want to make it simpler. Obviously, the coolest thing we could do is like lower the barrier to entry and then have an even higher ceiling as Unity. And that is really unrealistic. Just like how? If it were possible, Unity would do this. No, I think Unity set that threshold in order to enable you to reach this really high ceiling. But that threshold is unfortunately a little high. But by the time you want to solve all these upper problems, you're already quite committed. So it's an okay cost for them. And so these problems here, well, you can do them with whichever tool. I feel like if you already have the knowledge of my tools, you could just continue using my tools and solve the problems in this space. If you already know Unity, and this is the stuff that you want to solve, there's no need to learn my tools. So it's that simple. You can just look at it that way. And I think it's a really cool way to illustrate the power and the use of tools, and really also estimating how much learning is required in order to pick up a tool, and then again, what you can actually do with a tool. And this knowing what you can actually do with a tool, that is the really hard part, because unfortunately, the tool developers, the vendors, are not always very honest about that. And so that's something we need to improve. So this was a little bit of a fun lecture, but it's actually a really, really important one. And I wanted to give it this a little bit of a fun spin so that you don't see that I'm actually dead serious, but I am. So this lecture is really heartfelt and comes from years of experience as a PhD student myself, really trying to learn how this scientific community works, how to come up with good research problems, which especially in the XR space where so many things are going on is really, really hard. And then also from my teaching experience, both in traditional, relatively boring mobile and web design, interaction design classes, to some of the more advanced courses that I'm teaching now, that I'm fortunate to teach now, to both non-technical and really technical, highly skilled designers and developers. Because I want everybody to be able to participate in this XR design space. So I'm going to introduce you to these two piles of good ideas and bad ideas. And you can use them as a checklist, like the things that I say. If that is true about your idea, then maybe it's a good or a bad idea. Well, I don't want to offend you. I could still be wrong. It's just an intuition that I've developed over the years. So if you can say this about your idea, you're adding a significant new feature to an existing solution, that's a cool idea. Do it. You're doing a complete redesign of a solution? Well, actually, that's not a good idea. Let me fix this. So I'm going to go in here. You're doing a redesign of part of an existing solution. Now that is a good idea. Okay, let's look at it. So you're doing a redesign of part of an existing solution. Don't do the full redesign of something existing. Don't redo Amazon. There's probably something good about it. It's quite popular and stuff. So don't. So if you can say this about your idea, then you probably have a good idea. You're picking one particular aspect of a problem and try a different solution. Now, there's a big problem and maybe lots of solutions out there, but then you're trying to focus on this narrow thing and you're trying it slightly differently. That I think is a really good way. And this is similar to what I'm saying here. You're looking at an existing problem through a new lens. Now you're actually like looking at this whole problem and you're recasting it from this different lens. And now you're not coming up with the same solution, but you're coming up with a slightly different solution. And that solution might be novel or at least innovative in some way. Especially if that new lens is really a new lens, like nobody has looked at it this way yet. I mean, that lens is not new, but nobody has actually applied that lens to the problem. Then I think it's a very good way to innovate. And this is actually what a lot of researchers do, and it's actually a very good way to make progress. So, looking at the candidates for bad ideas. So if you can say something like this about your problem or your project, then may not be the best idea. You're just adding a small new feature to an existing solution. You probably agree with this. Unless you are the designer of that existing solution, in which case you're creating a new version of it, which is fine, you should really not be saying anything like this about your idea. You're trying to make an existing solution much better. Now, I've heard this all the time. So the problem with the much better part, well, in theory, it's a cool idea, but the problem is if you can't say the much better, if you can't quantify, if you can't specify in which way you're making it much better, then it's really a problem. So a good way to specify something like this would be like, I'm making it easier to learn it, or I'm automating this part, which makes it faster to do that part. And then you're trying to do what multiple existing solutions do in one new solution. Oh, yeah, you're doing the dashboard. Trying to wrap around things and then coming up with this whole new thing that brings everything together and makes it better. Not a good idea. First of all, if that is your project and you're like working in a class or something like this, you have only so and so much time. Actually, every project is time limited. So abandon that and refocus and reshape. Finally, you're trying to do what nobody else has done before? Really? Now, I've heard that so many times, and it's probably never ever true. The problem might be that you don't know whether somebody has done it before, so you haven't done your homework. You haven't read the literature, you haven't tried out the tools, you haven't played around with this existing technology. Maybe you didn't know about it. Well, that's fine. So run your ideas by people. It could be professors, could be other designers in your team, could be your users, your future users, or any kind of stakeholders. And that's a good way to shape and reformulate ideas. Now, if your ideas fall into these categories like the good pile or the bad pile, there's always room for improvement. Doesn't mean that if you're here that it's safe and you'll be fine. Doesn't mean that. You could still have introduce issues as you're executing the ideas. You're not really involving users, for example, when you're designing a new product. Now, maybe you had a really cool idea in the beginning, but you could still mess it up as you're trying to implement that idea. And so now these are not fail-safes or guarantees that your product will be successful. But really, if you're in this pile, you should really reframe your problem. A big problem is really about scope most of the time. You're taking on something too big, like the dashboard thing I just talked about. Rescope, make it smaller. Now, that's a good way to innovate as well, because it's easier to come up with new things in a much more constrained and small problem. Don't make it too small, shouldn't be trivial. That's the other thing that I sometimes complain about when I work with students on projects. So, don't make it too small. There should still be room for exploration, creativity, and in some sense, obviously innovation. And that's what this whole lecture was about. So I hope you enjoyed some of these lessons. In this case, I tried to be a little bit more fun than usual, and we cut this slightly differently. It's supposed to be stimulating and inspiring and not as serious, but there are actually really valuable lessons in here. I think these are cool techniques that help me at least try to innovate and come up with the next research problem. And maybe they'll also help you as you're thinking about the next solution for a real problem and a real XR solution in that space. Now that would be amazing. Storyboarding and wireframing. That's what I'm going to talk about in this segment. These are really important early stage design steps. So I laid out the larger XR prototyping process, storyboarding and wireframing, physical prototyping, and digital prototyping. We go through each of these steps, but in this segment, I'm just going to focus on the first one, storyboarding and wireframing. So storyboarding and wireframing, here's what we mean by this. So you basically sketch out the interface ideas that you have and organize those sketches into what we call a storyboard. And a cool element of the sketches is usually when they are a little bit more precise than usual, we call them wireframes. They're actually blueprints of the screens and potentially 3D scenes that we'll see later in our AR/VR interfaces. All right, and what I want to show you here is basically this is from one of our design jams where students were explaining to me how they have been thinking through this prototype of an AR furniture placement app. It was inspired by some of the products that IKEA and Wayfair have out there now. So you could choose between different types of furniture and then rotate, for example, the chair here, and also color and get like real previews of the furniture that you pick with specific choices like color and size. through a menu. And so this is how the app would work. What I find interesting about the storyboard is obviously it contains a lot of detail. You can really see how the AR interface blends with the 2D menus that you see on the left and at the bottom. And the students did really do a good job thinking this through. So what we just saw is actually just one example of the types of storyboarding techniques that I'd like to cover. So the way I'm going to do this is I'm going to think these different techniques. I'm going to introduce you to a few techniques here, and I'm going to think them through from low fidelity to high fidelity. And I'm also going to think them through in terms of like what I think is easier to do and what I think is harder, requires more practice and potentially technical skill. So the 4 techniques we're going to cover is storyboarding, which you just saw, so traditional storyboarding, which I think is good for organizing sketches into a story, and into a sequence. We're going to talk about 360 photo stories, where you would essentially use a 360 camera to capture physical space around you, and you treat these physical environments that you capture as like prototypes, as mock-ups of your virtual reality environment. So you actually prototype in the physical space, come in with the camera, capture, and create content that you can later use in VR. Pretty powerful. And then I'm going to talk about 360 storyboarding. This is actually something that I've worked on and looked at in detail in a lot of my own research. I believe in some of these techniques. A little bit harder to do, but I think they're actually very powerful, especially if combined with some of the tools that I've been working on. And I'm going to show you why this is a good technique for storyboarding and why it allows you to think around the user, which is really, spatially thinking around the user is really important for AR and VR interfaces. Finally, I'm going to cover 3D storyboarding, where you're like inside a VR headset and you're sketching out essentially the 3D world around you, which I think is a very good way of visualizing in 3D, but it also requires quite a bit of practice. It's the closest to the final prototype if you want, but it's still a storyboard, so keep that in mind. So now I'm going to walk you over each of these techniques in a little bit more detail. So 360 photo, remember, we're going to use a 360 camera. We're going to capture an environment, like for example my lab in this example. The way it looks initially, very distorted, different types. This is accurate angular projection, so different formats in which these cameras actually capture this. But what you can do with it, you can actually map it into a 3D sphere, and that 3D sphere is essentially around the user. And this is how 360 photos and videos that you may have seen on social media, this is how they actually work. You map it back around the user. Okay, so here we are like in my lab, and you've probably seen these experiences before. So this is 360 photo, and it was obviously captured at this very position. In this case, it was captured by my former postdoc, Max, in the lab. And it actually shows, it's a capture of when we were just starting out in my lab. We didn't have as much equipment as you can see. You may see later portions in this MOOC specialization where we have a lot more stuff in the lab, and you will not even recognize this anymore. But as you can tell, we could use this 360 photo now and actually prototype a virtual reality application for the lab. We have relatively good understanding of the spatial layout of this room. And we may also even use this as a placeholder for the environment and prototype AR experiences without actually being in that physical location. Okay, and if you now put several of these 360 photos together, you can actually build a story, and that way prototype, for example, what it would be like to walk through campus, like at the University of Michigan, or like finding my lab, finding my office, and those kinds of things. And this is a traditional way of thinking of photo stories, but the way I'd like us to think about it is like as a way of storyboarding interactive experiences. Some of them may involve navigation in this traditional sense. They could also be different steps in a sequence in an interaction technique. So we will spend more time with some of these techniques in the activities that I have designed for you. But this would be 360 photo storyboarding. Okay, so here you can see this 360 photo story in sequence. Basically, Max took these photos, and then he was going down the stairs, and you can like experience that from these different perspectives, and you get a sense for, oh, he's actually walking towards the lab. And this is a pretty standard photo story, the way you could think of it. But each of these 360 photos would give us an environment that we can actually prototype for. right? We have relatively good 360 overview. We could do something when people exit the elevators and come to the School of Information, or when they, for example, come over to my lab and we have a lot of visitors in my lab. And this is the photo that I had earlier. And I show you this in a prototyping software that I'll make available to learners, and it's a very good way of creating 360 photo stories and actually prototyping out different kinds of interaction sequences. For example, here are standard navigation tasks, but there could be different steps in a multi-step interface with different changes to the interface. Let's come back to the idea of 360 storyboarding. What you see here is a template, and the way this works, and it's described in more detail, is this is what I would see right in front of me. If I follow some of these grid lines, I'm basically sketching content that appears above the user. Similarly, this would be content that appears 90 degrees to my left, 90 degrees to my right, content that appears at the bottom. It's actually a really powerful template. And in some of our activities, you can explore this template in more depth. I want to show you a couple of examples of what we can actually do with this template. So what we have done is, for example, creating a scenery where we put butterflies in the middle. So the user will be seeing these butterflies, and they have a doggy and a car. And then we add a second layer to it where we actually then show trees, and we're starting to prototype on paper, storyboarding still, out this scene where you're suddenly in this environment. So now we have 3 layers: mountains in the background, the doggy and the butterflies in the foreground, and the trees in the midground. So how do we do this? Yeah, I just explained all these layers to you. And then what will happen is, if we add these ideas from 360 photos that I talked about earlier, we can map them onto a sphere. And now the user will be navigating inside the sphere as they put on their VR headset. And the way this works then is that they actually just see this experience prototype. It will be actually flattened out in some sense. And I've just have this experience: doggy, butterflies, trees, and mountains. Okay, so now I've composed the scene, and you can see a little bit of parallax. So we're basically spreading out these layers that we have between the foreground, the midground, and the background. And this gives this effect that now we can actually walk towards these butterflies. And we can turn around and can see the doggy and the car, and the trees are there. And so we just composed this from 3 layers of a 360 storyboard. It's actually really quite cool. And you can play around with these parameters, like how far do you want each layer to be separated from the other, so to create a more realistic experience and preview. I've talked about foreground, midground, and background, and now what we can also do is actually move out some of these spheres that we are mapping these 360 storyboards onto. And so we can create an experience like the Star Trek experience, where it's possible for the user to actually walk into the observation deck that is just next door the bridge. And I'm going to show you this as well in a quick example here. What I'm going to do now is walk around, and I'm going to walk into this room over there. So we have to walk around the bridge, a little bit physically constrained here, but the beautiful thing is that this room nicely, the physical room nicely maps into our AR version of it. And like in the room, and I have some see-through effects here, and we can go back into the other room, hop, 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 and there we have space. This is actually the film studio where we're working, and we're back at the captain's chair. All right, I talked a lot about storyboarding, and so in this case I want to specifically focus on 360 storyboarding. Now 360 storyboarding, I brought like basically 3 examples here, and I want to briefly show what is required to create those examples. So one of the things you see throughout the course is this scene with the doggy and the butterflies, and then we have a little bit of background, like the trees here, and we have mountains in the background. And I explained how these are different layers, and that we can then kind of like remove the white and layer them and actually have a really cool experience that way. Now, the way we created these is through a 360 grid that I kind of like tried to line here. And you can see that the butterflies are in the center. And I talked about this grid in a lot more detail. So next, I briefly want to talk about what it's like to
prototype an existing experience. So if you are familiar with the Star Trek, this is the bridge with the captain's chair, and that's the bridge behind. And then what we also did is we actually created a room that is the observation deck. And when we create this experience in VR, we can actually move these spheres so that they're intersecting. You can actually walk over into this other room. Now, what is very interesting, when we created this experience, this was actually an 8-hour prototyping experiment with Katie, a very talented designer in my lab. And we also used additional tools. So one thing that we were actually really a little concerned about was the amount of movement that is required to really explore the Star Trek and what users would see initially when they start this experience. So this is giving us the range of motion of a user when they are seated in VR. And to be honest, this experience, the Star Trek, we prototyped for both VR and for AR. So the more interesting thing for us was the field of view. So what would a user, especially when they are starting out, I will show you later the final experience to the user, but when they're starting out, what would be the initial field of view and how much of the bridge would they actually see? And so these are some useful templates and tools that I share with you so you can actually prototype some of these experiences and learn about how to do this actually well on paper. One of the issues with paper is that things often appear different in terms of scale, and so you will actually have to experiment a little bit with this. So a good way of prototyping this is actually putting a blank sheet of paper on top of our templates and then see the pattern shine through, and so you can orient yourself around the center and actually start drawing content in the middle, content that would appear, and then content that would appear to the left of the user would appear over here, content that would appear to the right to the user, so 90 degrees to the right, you draw in there, and you can also draw the top and bottom, so you can actually draw 360 around the user. So it's a really powerful template. Finally, one way we often use this is actually, if you want to prototype experiences for my lab at Michigan, we also have a template that is essentially a 360 sketch of my lab. Now, we wanted to try out how difficult it is to prototype rectangular rooms using a 360 template. You can see lots of distortions here, just the way it is. But when you actually view it in 360 on a VR headset, it will be evened out. It's like it goes around the user. It's like wrapping it around their head. And so these, what appears to be distorted, are actually rectangular shapes, and then suddenly they become windows and walls. And this is a very good way of using VR techniques to prototype AR experiences. Finally, once we have created some of these prototypes, we often use cardboard to rapidly preview these kinds of things. And I'll introduce it to tools where all it takes is like put your phone in there and take a picture this way, and then start previewing the experience in VR. It's something I'll talk about. And then we'll also talk about some of the AR ways of prototyping things, where we make use of markers, fiducial markers that are visible to the camera. And so when we prototype these experiences, we not only work on paper, we often want to actually quickly preview things in VR and in AR. And so the way we often do this is, at least in my classes, we use software that I've developed that can run on our phone. And then all we need to do is actually put the phone inside cardboard, run the software, take a photo of the experience, click, and then preview it in VR. And these are things that I'll actually show you throughout the MOOC. And we can do similar stuff for AR. So I also brought a few paper markers here that are popular, and there is a cardboard version of AR, which is called HoloKit. And so, same idea, phone goes in there, the experience looks a little bit different. You have to make sure that the camera is exposed, otherwise it will not work. So it has to go inside this way. And we run the software, we put it on our heads, and we actually use these markers to tell the phone where the coordinate system of our prototype, and then we can actually preview fairly quickly any of the things we have prototyped here, actually preview that in AR.
So I've talked about storyboarding, I've talked about 360 photo stories, and I've talked about 360 storyboarding. None of them are actually 3D, and so this last technique is storyboarding in 3D. All right, I want to show you 3D sketching. And the way I'm going to do this is I'm actually also explaining to you how we actually created this experience. So what I'm doing right now is actually sketching out the room that I'm in, okay? And it is, as you can tell, it's already a 3D kind of room, but there's nothing interesting in it. So where is Michael in this room? Okay, so this is pretty easy. I'm kind of like here, standing and waving at you, so that's me, okay? And you guys are at the other side of the room, obviously. The camera is roughly here and it's pointing towards me. And you can see it. I'm never sure which is the best perspective for you guys because it's like 3D, but you know, this is kind of like the experience that you get. And how do we do this actually? How can you actually be part of the experience? So the way we record this is there's actually a green screen behind me, okay? Now, this is what it looks like. And well, you don't see the green, right? You have this really cool, interesting background behind me from Tilt Brush. And the way we do this is we're using software that is essentially removing the green screen through chroma keying, so it's gone. And we can fill in some really cool stuff in the background. We could actually do anything. We could have a rainbow or other things behind me and create a really interesting experience for you that way. And obviously, while this sounds like movie production, I mean, as you can tell from how I talk about some of these concepts when it comes to XR, it actually seems very related. There's a lot of technologies that blend and blur between movie making, virtual production, and actually AR/VR content creation. Now, this is a 3D sketch, and it's very useful in the early stages of design, but it also is actually could be one of your first assets. You could actually export this into other kind of AR/VR software and process it further so that it can appear in AR or in VR, which it is right now, but we can process it further, as I said, and could really do a really cool experience that way. So I've introduced you to 4 powerful storyboarding techniques, and the extent of wireframing really built into these techniques really depends on the type of storyboard that you're creating. So if you're paying attention to the detail, the traditional storyboards are usually very rich in terms of 2D wireframes, but traditional storyboards are quite limited when it comes to AR/VR scenes which are in 3D. So I've introduced you to 2 additional techniques, like the 360 storyboarding technique, which allows you to plan layout around the user. In 360 degrees, but you don't have depth. It's not really 3D. So the last technique I was just talking about, 3D sketches, really allow you to detail the content around the user, plan it out in 3D space. In fact, you know, draw it in 3D, and then you can actually create assets that way and download them and process them further so that they can actually become elements in your final AR/VR experiences. I want to wrap up with a few tips here. So I would say start with the high-level sketches first, add gradually more detail, but only what matters to the experience. For example, don't focus too much on the physical world around it, only on specific elements that dictate the AR or VR experience. For example, if the room that you're prototyping for has a very particular shape, then you should really pay attention to this. Otherwise, it's just a rectangular environment, and you don't have to draw out every wall. What I've noticed a lot is really when I work with my students, and there's this implicit notation that comes up that people use to distinguish between drawing out the physical elements and drawing out the virtual elements, really the overlays. And so what I often see is, like, for example, color being used. So red is virtual and green is physical. And if that is used consistently, it really becomes a good notation that allows you to communicate how these storyboards actually translate to design and later design specifications when you work with developers. Finally, I would communicate the type of devices being supported. I would pay a lot of attention to what kind of experience you have in mind. So keep in mind, we have lots of different types of AR/VR. It could be handheld, it could be head-worn, and you should really keep that in mind even at the storyboarding stage. However, at that stage, we are still brainstorming a lot, and storyboarding is a very powerful tool for brainstorming new kinds of experiences you want to create for AR/VR. Physical prototyping. That is really one of the most important lectures to me, and I've actually split it up into 2 lectures here, and I want to introduce you to a few physical prototyping techniques. So physical prototyping is really in the larger XR prototyping process. It is actually between storyboarding and digital prototyping. And I think personally physical prototyping is very powerful, and it's actually worth spending quite some time on it because it'll save you a lot of time later. If you get the physical prototypes right, you learn a lot about the digital prototypes and you cut some corners there, iterate faster. And that's why I think this is really important in the larger prototyping process. So I'm going to show you a few examples of physical prototypes created in some of my classes and in some of our research. Okay, jumping right in, this is from one of our design jams where I was prototyping an AR furniture placement app with students. You can see that the final experience is supposed to be on a smartphone. There's a menu at the bottom, and the user can choose different options to switch furniture. So in this segment, I'm actually going to talk about a few different kinds of techniques. I'm going to use the same analysis we did before. How do we move from lo-fi to hi-fi? And what are the techniques in terms of their relative difficulty along the easy to hard spectrum? So we just saw this example of paper prototyping, which I think is a very good way of thinking through at least the basic interactions. Might be too limited for some specific AR/VR interaction techniques that you need to prototype. And so I'll also introduce you to 360 paper prototyping, which is basically taking the 360 storyboards that I showed you earlier, taking these ideas further to the next level so that it's actually possible for users to quickly prototype on paper and then experience those prototypes in AR and VR. I'm also going to talk about dioramas. Dioramas are miniature 3D physical prototypes of the AR/VR scenes we want to create, which I think is a very good way of thinking through proxemics. And by proxemics, I mean the spatial relationships between the people, so the users of our AR/VR experience, which could be more than one, and the devices that they use, as well as any kind of physical and virtual objects in our AR/VR experience. And you can prototype all of this physically without having to do anything with digital tools. Finally, we're going to talk about physical prototyping by actually using modeling clay, which I think is a very fast way of modeling quickly in 3D. Personally, I'm not very good with 3D modeling tools. If you have an architecture background, maybe you want to skip this step. But in general, I think in the larger physical prototyping workflow, 3D modeling with clay is really good for creating the main 3D characters and acting out the stories physically before you implement them. So starting from paper prototyping, there is this popular paper from 1994 by Mark Rettig, Prototyping for Tiny Fingers, which introduced this idea of using paper prototypes for testing. So you can actually have multiple screens available. You need to use a few people in different roles. There's obviously a user trying out that experience. There's a facilitator running through the test. And then there's a person called a computer that's a person, a human, that actually produces the screens by choosing from the different assets that designers have previously prototyped. And then there's a note taker as well. So how does this idea actually translate to AR/VR prototyping? Well, we have worked on this, and in some of my research, which I'm talking about here, a project that we call 360 Proto, we've taken these ideas further. So now we have our user in VR or in AR. We still have a facilitator. That facilitator also has an additional task of actually capturing some of these mock-ups that we produce on paper. We still have the computer person. The computer is still producing the assets, but we're using specific templates that I'll go in a little bit more depth here. These 360 storyboarding templates I talked about earlier to really create 360 paper prototypes. And I'll show you a few examples throughout. You can bring them to life and actually have test users experience paper prototypes essentially in VR or AR. Really quite powerful, and I'm excited about this, so I'm going to show you some of these techniques throughout this segment. If we think of paper prototypes, we can distinguish just traditional paper prototypes, which don't use any specific templates, and 360 paper prototypes, which make both the prototyping experience a little different and also the final user experience, as we will see in some of the videos I'm going to show you now. So if we stick just with paper prototypes, what are they really good for? Well, they bring storyboards to life. And that's actually what we do as we take a storyboard and explain it to other designers. Using a paper prototype, you can do the same with users. You can actually demonstrate interactions in front of the user. The user can perceive this prototype with some imagination, obviously, to understand how these translate to AR/VR interactions. What you can see in the image is how we use, for example, cardboard sticks or toothpicks. In some later examples, you will see how we put Play-Doh figures on toothpicks to really animate the objects relatively seamlessly in front of the user so that they get the sense that this is actually an interactive prototype, even though it's still on paper. So here's an example where one user with a VR controller is pointing at forest animals, and some of the designers around the user are actually animating these animals and respond to the user's interactions. And it's quite an interactive storyboard in the sense that you could have new elements appear, like in a second there will be a froggy triggered by the interaction with the VR controller, and this really helps the user understand how this VR experience is going to unfold as they interact with different elements like these forest animals. Now, if we prototype that same experience with 360, things look a little bit different. You actually have to pay attention to the template and move the elements like these animals accordingly. So you can actually now lay out content in 360 degrees around the users, but pay attention that the grid actually means that, and so you can't just move objects too quickly. You really have to follow the grid lines. Requires a little bit of practice, but is actually a very powerful way of prototyping 360 experiences. You can demonstrate interactions along these grid lines, as I said, and that will actually make, for example, something fly around the user. And you can also use objects of different size to simulate depth. Remember, 360 photo stories and 360 photos, as I mentioned earlier, don't actually have depth. It's not really 3D. And so one way to simulate depth is actually using objects of different size. The way this works is a designer is prototyping a bird flying down, and we are now actually, this owl has now landed on the tree, and we've just replaced essentially the model. Our deer is coming in, and this was an experience of prototype with students. We are not particularly careful with paying attention to the grid lines at this stage. We were still getting familiar with the template. But I'll show you how we can actually take this storyboard to the next level, because the idea is that you can actually capture this and this video and actually play it back in 360. Remember, it follows the 360 format, and we can actually then visualize this paper prototype for VR users. So this is what I'm going to show here quickly. We can compose a scene, putting the 360 grid template on top, and then adding the elements that we actually want users to see. Now you're spacing them out, you can cut them out, you could sketch them, you could draw them as you did with the storyboards, but I think for paper prototyping, I would usually work with paper cutouts. You can animate more easily, you could swap out models. It's actually really powerful. And then you can compose a scene like this way. Okay, and because this is actually still following the 360 template, what we can do now is we can actually take a photo close up of that template, wrap the photo in cardboard, and then experience that in VR. I'm going to illustrate this quickly. Okay, this is a close-up of the paper prototype. We take the picture, we go into VR, and we see it with stereoscopic views. And I'll show you the same in a video. So this is me taking a picture of a previously prototyped experience. I click the button, the phone is already inside cardboard, and I can start previewing, in some sense, pre-visualizing the 3D scene. You can see the grid lines. We could remove this layer of grid lines if you use transparency or other kinds of means. But you have a very quick way of visualizing a paper prototype. Now you can actually have a facilitator or a computer, a human computer, make adjustments to this scene composition. And now, as we can see, the owl has moved a lot closer. If you combine this with live streaming, you can actually simulate interactive 360 storyboards, and this is something you can read about later, where I share some of my work on 360 Proto. What is a little bit tricky is actually creating AR previews this way. And what I'm going to show you now is an idea I've developed in 360 Proto, the research project. We're going to take the 360 template, we're going to map it, we take a photo of it, we're going to map it into a 3D sphere, and our goal is to actually animate a butterfly around the user, or at least have a butterfly stuck in the air, and so that the user can actually walk around, the AR user can walk around and actually experience that butterfly. What I don't do this in this example is actually moving the butterfly, but you will still see a really cool effect here. So how do we prototype this? Well, we can use additional AR techniques like markers, like a physical marker here. We can use a phone to capture that and live stream that. and we can then actually take that picture, remove the background, white becomes green and then actually becomes transparent. We extract the butterfly and we show it at the very location. And the way we do this is we're using the 360 grid again to keep attention to where the object is around the user, and we're replacing that marker with actually our virtual overlay, which in this case is the butterfly. Okay, let's experience this. So this is actually me working with my student, Katie. We are actually now having this butterfly kind of like move in front of our camera, and we're live streaming this to the other phone that you see in the background. And what I'm going to show you in the next step is actually how I'm going to take up the phone and then we have the butterfly there. And because we're using AR techniques with the camera, the smartphone camera needs to be exposed for this to work, we can actually walk around this butterfly. At this stage it is still. Again, if we were live streaming this to the VR or AR user, we would have a really cool experience that way. So this was just the first part of physical prototyping, but I wanted to illustrate to you how you can actually take paper and make it digital. A lot of this is obviously described in more detail in some of my research. I and others have worked on this, and I hope that we will have better tool support in the future. In the meantime, I will give you access to some of the tools that I've created in my research. Physical Prototyping 2. This is the second part of my physical prototyping lecture. Because physical prototyping is so important to me, I made 2 lectures out of it. And in the previous segments, I've talked about paper prototyping and 360 paper prototyping. And now there are 2 things that I really want to talk about a little bit more, which is working in physical space and with physical modeling tools. So we're going to talk about the diorama, which is good for thinking through proxemics, really the spatial relationships between all the elements of our AR/VR experience. And then if you're not good in 3D modeling, I don't blame you. I'm not good at it either, but I can actually do it with Play-Doh. So I'm going to talk to you a little bit about 3D modeling with clay, which I think is very good for creating the main 3D characters. So the diorama is essentially a 3D physical, often miniature version of a set, like a 3D scene or an AR/VR scene that we run a prototype. It actually allows you to enact that 3D scene in the physical world. You can use multiple designers to help each other and then give that experience to a user. As before, you can actually demonstrate interactions to users. In this case, what often happens when I do this with my students in class, really the students become actors. They really play out the 3D characters in response to user interactions. So it's really cool to see. And a side effect, and actually very useful for learning about this prototype as we move it digitally, you can actually gauge the spatial requirements and understand the relationships between the different physical objects that you're using to prototype that AR/VR experience. I'm going to show you an example from something we've prototyped in my lab. It's again this forest scene that we like. So there we have the owl fly in, and then somebody interacting, and now this owl was replaced by a different object. Now this looks a little weird because we chose this upper angle and we have played around with different types of stages, but the main takeaway here is that it's actually a very good physical representation. All the pieces you had to fill in previously when thinking just on plain paper in 2D or thinking around 360 and using our template from before, actually working in physical space makes things so much easier. So at least that's what my students tell me, and that's what I also personally feel when I translate some of these paper prototypes into dioramas. Obviously, I would like to share a lot of the work I've done with my students in my classes and in my research. So here's a quick selection. We have, for example, prototyped VR gardening experiences using dioramas, or we have talked about this public speaking experience, which actually creates a lot of anxiety. And you can prototype out a TED Talk this way if you want. And some of my students have also prototyped an immersive theater where you can actually Here you see a 3D version of the stage, and later it'll be in VR. And so dioramas are really powerful to actually prototype out these techniques, often in a matter of 45 minutes. You can do this in class with designers of any kind of background, and you don't actually need a lot of technical skills and any digital tools, which I think is actually the cheapest and fastest 3D tool that is out there, physical space. And a diorama might be a very good way to do this. So the last technique I want to add to our portfolio, and you've seen this to some extent in previous videos, is we often use 3D modeling with clay. Here I show a few of the examples created by my students, coming back to this idea of prototyping an AR furniture placement tool. So the way we often use 3D modeling with clay is we actually focus on the main characters of our scene. And then these storyboards we used previously are now becoming physical. And you can actually capture nicely what these 3D characters do. They actually come to life, and they actually are in 3D. They can be moved in 3D, they can be rotated. And you can actually get a sense of the complexity of the 3D models you need to create later on. And you also can demonstrate interactions again in real 3D. It really makes a lot of things easier. However, sometimes with some of the interactions, you really need to coordinate better between designers and users. So this requires a little bit of practice, as we can see in one of the videos I'll show you in a second. So here's an example where we are trying to coordinate between user and designer. The user is performing a rotation gesture, and the designer, in this case, the computer, the human computer, is moving the chair accordingly. So the students have just prototyped this experience quickly and got a sense of the interactions they want to support in their AR furniture placement app. And this is a really cool way of getting a sense for the physical space and actually creating 3D assets that way as well.
Great. So I've brought a few physical prototypes here, and what I want to illustrate is how you can actually prototype interesting concepts for both virtual reality and augmented reality using just physical prototypes. So I've prepared 3 scenes here, and there are different ideas behind each of these scenes. I'm going to start with this one. So this one was actually a project that happened in one of my classes. The students were interested in using virtual reality to prototype a standardized test scenario. So a lot of students actually are afraid of standardized tests, usually really big audiences, really big rooms. And so what this prototype allowed them to think through were like the basic interactions, who are the characters, and what would be interesting perspectives. So the experience, if you are in the front where you can always see the door, might be very different to like sitting behind a bunch of other people in this kind of like standardized test scenario. It might create more anxiety. And so VR is a very powerful tool for building empathy. And so this is actually was one of my favorite projects from some of my students in class. This was also a really, really cool idea. Here the idea was to bring language and culture closer to the audience. In fact, this was about Chinese food and all kinds of really good looking food. In fact, this looks so good, I would really like to eat it. But it is actually made of clay, and so you shouldn't. And so there were additional elements that I don't show here right now. I just focus on Play-Doh and the physical aspects. But there was paper, there was actually Chinese language around it. The idea was to really prototype an experience so that learners can learn about different language and culture. Now, these were 2 examples of prototypes that allow us, that are new ideas in some sense, that allow us to think through interactions. And these are some of the things we practice in our physical prototyping activities. Now, this is a last scene that obviously, if you are familiar with some of the movies out there, this should remind you of The Lion King. Now, what we've also tried in a lot of our research and also in some of our student projects, we have actually taken existing scenes and recreated them. Here you see Rafiki, and we actually had to do 2 shots of Rafiki, and you may see this in other portions and other segments of this MOOCs visualization, where we actually animated Rafiki, especially this one difficult scene where he was like moving the hands apart and breaking this. It's a really nice element in the teaser, and this allowed us to think about character movement and complexity of 3D models, and that's what you learn from doing everything physically. When you start analyzing these physical prototypes, I believe you get a lot of knowledge in terms of requirements, what kinds of user requirements do we have, what kind of display requirements, tracking requirements, what does this mean for our 3D models, how complex is this stuff, can we download existing ones, do we have to create our own ones? And so doing this with Play-Doh in the matter of an hour. You can do this in a classroom setting. You can have students think through this very quickly, and I'm a big proponent of physical prototyping.
So in the last two segments, Physical Prototyping 1 and Physical Prototyping 2, I've introduced you to a variety of physical prototyping methods. For example, just using paper, then adding the 360 grid onto paper, and then using clay and the dioramas. And what is most fascinating to me is that these physical prototyping methods are largely AR/VR agnostic, unlike digital tools, which are often just really good at AR or VR, if at all. And physical prototyping is really fast and cheap, and it's really allowing you quickly to iterate on designs. However, keep in mind that when you prototype physically for VR, it's really about the immersive experience and this feeling of creating presence. So you should really pay attention in your prototypes to creating this virtual environment. For example, using the 360 grid, because this is the best method that allows you to think spatially around the user. However, for AR, it's really about augmenting experiences and context. So context here is really referring to the physical environment that the user is in. So your AR device would read this environment and then send signals to your interface. So what you need to pay attention to is when you prototype AR experiences, the tiny little things in the physical environment around the user that could trigger certain aspects of your experience. In this video, I'm going to introduce you to the XR storyboard exercise as part of our XR design project. And so we are now in the storyboarding and wireframing stage. So that means we are brainstorming essentially. We want to focus on new features as we think about the expeditions like XR app that you have chosen. And so part of the exercise is really understand the existing flow without thinking about new features, and then also developing one new feature. So that's all I'm asking, and it's important. Don't try to come up with your own complete app. That's really hard for other learners then to provide feedback and help you improve your storyboards and wireframes. So it would be good to ground it in something that is not too complicated. We don't need forever to understand what the problem is you're trying to solve. No, we want to focus on the things that matter when we do storyboarding and wireframing. So really focusing on the key design ingredients, if you will. So here is my exercise cheat sheet. This is what I have in mind. So the task will be to create a storyboard for an expeditions like XR app. So one storyboard, one type of storyboard is fine. You should create probably a few different kinds of storyboards ideally, but let's say you do one storyboard, you should start with 2 to 3 high-level sketches. So capturing the flow of the app. You really want to understand how does this actually work? How do you transition between states, if not screens? And how does it work? And then you actually start sketching out. You can just sketch out some of the existing screens as well, or scenes, or whatever we should call it. And you should add more detail and distinguish, obviously, in your sketches, the physical and the virtual objects. So, for example, using color coding. You should annotate your sketches with arrows and labels, anything that helps us understand what you've been sketching. Usually a short label is very helpful. For any kind of key elements in there. This really drives the attention. Now, my sketches look ugly most of the time, but that's just because I only sketch what I want you to focus on. No, that's not true. Yes, so we don't judge each other's sketches in terms of aesthetics. The whole purpose of a sketch is to convey an idea. And so you want to only sketch what is necessary, only the resolution that is required, so that you can, get the other person's attention on your idea and help you refine it and improve it. And so it doesn't have to look beautiful. In fact, it's great that my stuff doesn't look good. Then you don't feel intimidated by it. And I think that is nice. Wouldn't it be worse if I were like a really good artist? Anyway, so you annotate your sketches. I just covered that. and you should actually then create 2 to 3 alternative wireframes of your new idea with content. I would like to see what we're talking about both in content, but I really care also about the flow and the interactions. How do I get to these new screens and scenes that you have prototyped? And optionally, but I think this would be a really good task, and I say optional because, well, to manage your workload, but also normally in a project you wouldn't actually try out all kinds of different types of storyboards, but I would like you to try out a 360 or a 3D storyboard. So the expected results of this activity and exercise are that you have a better understanding of the overall flow of the app, and you also have more concrete ideas of how to change and improve the design, including a new feature that you think could be cool, and you have a good sense of what your app may feel like in AR, VR, especially if you use a 360 or 3D storyboarding approach. So again, we are going to stick with a expeditions-like AR or VR app, so an XR app. Can also do 360, and it should work on smartphones like this one does, and that way other people can also try it out. So here's the one that I was trying out. This is the solar system. You've seen me do it, you've seen me critique it, and this is, I'm going to show you a few videos of me brainstorming and storyboarding around it, and also then creating a few wireframes. So here you see screenshots from my design critique as I was playing around with the app, and that is really the input here. The function is to create a storyboard, and the input parameter is your existing critique. So your experience of trying out that existing app. And so I've covered all the kinds of screens and states of the app that I could reach and that were in the scope of my critique. And here I'll show you, this is from the lecture. So we have a few different kinds of storyboards. They vary both in terms of the fidelity, as I said, so lower to higher fidelity, and easy to hard. And I'll talk about this, or talked about this in detail in the lecture. And so I'm going to show you examples of each of these types of storyboards. First, traditional storyboard. So here you see a time lapse of me doing the exercise, and I was, I had already sketched out the basic flow. So this was just the flow and then the start, and then I was like developing my own new idea. And while I was actually developing my own new idea, I was also playing around with the existing app from time to time, just to get to really to flesh out some of my ideas, get a better understanding. And some of the things I really wanted to do was actually see multiple planets in relationship to each other. And then I had even more ideas of doing different kinds of day and night, and wouldn't it be cool if Earth, how would Earth look at night? And really was interested in the relationship of the moon around Earth and how it fits into this picture, and how far is Earth away from the sun anyway, and then other planets I didn't even care so much about. I was just focused on those 3 planets. In the original app they had more planets, but they didn't actually do much about Earth and Moon and Sun, like no relationships. And so I was really figuring out what could I do to improve upon some of the things that I think were missing from the app, from the existing expedition. And I understand that this Google Expeditions framework might be a little limited. So all these expeditions work in a very similar fashion. And so maybe there you could see, hey, that was a break, me thinking about what I could do. And then I had this idea of doing different night times and day times, and seeing really the zones like on an airplane when they show you this world map and show you where it is day and where it is night right now. And I thought that could be cool. And yeah, so then usually I do kind of like a walkthrough and illustrate some of the ideas I had in mind. And this is also, obviously in not 500 times speed would be a good way for you to share your results. And I have each of these steps recorded, so you can watch me do a storyboard. I'll share that video with you. You can watch me actually review my own storyboard. That gives you some ideas of maybe what to pay attention to, and also what you can learn from these storyboards. So the reading between the lines is really important when it comes to these activities and exercises. So I'll share those steps and videos with you, so that may help you guide through each of the steps even more. And then I was doing a 360 storyboard. So now we're down here, right? A 360 storyboard I think is harder because you're using a template that you may have to, well, spend some time with and actually understand and get a feel for it. And then I would say on the fidelity scale, it actually moves you more like here rather than here or here. I do think that fidelity is actually really quite high. It is not as high as a 3D storyboard, but I'll show you, and I actually share an app with you so you can actually take pictures of your storyboards and then preview them in AR VR. And I think that helps you cross this line and brings you into this quadrant, the one that we want to be in. Ideally, you want to be here, right? Super high fidelity and super easy. And well, I can't claim that for the 360 storyboarding approach. Obviously, there is my research on 360 Proto, and we've really worked quite a bit on this. But I think it can get you here, maybe, but not much further than that. So this is the template, and this is what you see right in front of you. This is 90 degrees to your left, so over there, 90 degrees to your right, over there. And this is right above you. This is, oops, down there would be right below you. And then it actually also, like, because it stitches on the sides and the top, it really wraps around your head. Like, that's how the 360 template works, right? Think of 360 photos. This is equirectangular format. So I was talking about this in more depth and detail in the lecture. But, you know, sketching like a rectangle, you would actually have to follow these grid lines. Okay, you follow these grid lines, you go down here, and you follow this grid line back, and you just sketched a really big rectangle. It didn't look like a rectangle, but it will look like a rectangle when you then do this transformation. And this is a projection from equirectangular to spherical. And I was just talking about this, so these are the things that are right in front of you, would be here and left and right. This blue cross, keep that in mind. We even entered all the degrees, and there are templates, and you see me use some of these templates to help me check for the field of view and the range of motion. This is something that I would do in VR. And you see the templates here, so they are like lying up there, the transparencies that we printed out. I'll share those with you as well. I think they're a little bit more advanced and not even necessary, but it's still kind of cool. And so here you see me sketch it out, and I'm doing a storyboard. This is the more interesting one. I didn't really play the other one. And I was playing around in preview. That's really important. And then I was checking for the field of view and the range of motion. Really, how much would the user need to move initially in order to keep things in view? And this assumes a standard VR headset. Now, since I was actually more thinking about AR, this was a little bit more like a demonstration, just to show you that it exists. And this app is really quite cool that I created, so I'm going to share that with you. It should work on your phone, hopefully. It is research, so don't hate me if it doesn't work on your phone. It works well on my phone and on Android phones, on a variety of phones, and we can probably configure it for your phone too. And then in between I sketched out just using the normal, well, traditional paper, and now I'm moving this sketch to the 360 template, and I should share, I could share that entire video with you. I do think that I was sketching for like 20 or 30 minutes. It's probably a bit long. I was thinking we just look at the time lapse, and well, and then I was using color. So that color is actually quite important, because as I was talking about in the lecture, you should really mark the virtual content and tell me what's virtual and tell me what's physical. And here I used red as annotations. So red wouldn't be displayed, blue is the virtual content, and black is just the reality. That's the notation that I have established for myself. Like, you don't have to use it exactly like that, or do it exactly like that, but you have to be clear how you were thinking about it. Here is the result. I'll share that video with you, definitely, because rather than watching me sketch forever, this is the one where I'll talk you through some of the results, and that will give you some inspiration. So we're going to share that 360 storyboard video, and you can watch it in full length. I was playing around with a template and really getting a sense for how things work, and then I was applying that template. So here, for example, I show how the template really works and how I applied it to paper, and how I was then sketching out the planets, and then also previewing the planets in VR. I also have a video for you where I'll actually preview the storyboards that I have sketched, and so you can see what this might look like. I hope that you will be able to try out this app and it runs on your phone. This is not a product, this is a research prototype coming out of some research from my lab. It's a simplified version, not as advanced as the one that we actually had in the paper in 360 Proto, where you could live stream and use multiple phones and all that kind of stuff. But even this simplified one is already good enough for us to get an overview or a preview and actually transform paper into a VR interface, especially when you then combine it with cardboard. That is then really cool because you really get a preview, a VR experience. And here is that example where I then actually put it in cardboard, and then put obviously the actual cardboard, use that with the device. So okay, so we've seen the storyboard, we've seen a 360 storyboard. I don't do a 360 photo story, but again, the idea would be I just like do it in the physical world and then I take 360 photos of it, or any kind of standard photo story you could do as well, but I think you would learn more from a 360 photo story, and I described that in the lecture. What I've done for my own exercise, I have done the 3D storyboard, so I'm going to focus on that. So I have a 11-minute video of me actually going through that storyboarding activity in Tilt Brush, and really I was using Tilt Brush in a way that it's probably not really being used for as a storyboarding tool. Keep in mind that Tilt Brush is not a tool that is for free, so there are other tools out there. I've played around with a few. You see me use few other tools later. Quill, for example, is one that you could use on the Oculus, and there are a number of sketching tools out there, and then it is on you to use them as a storyboarding tool. The way I've done it here is like sketch out different stages or scenes of the app, and I was doing it in VR, but I'm actually sketching an AR experience, and I'm sketching a little crazy here. This was really supposed to be a glowing sun, and first step was like place the app. The second step was to then see the sun, and then I also wanted to really understand the transition between these different steps. And later in the video I then review some of my work, and then I use it like a user, and think it through and think aloud and mark like the interactions that users might do. And then I was picky with the color for some reason, but that's just being me. Anyway, this was supposed to be blue, I guess, and I was looking for the right blue, but come on, Michael, focus on the task. And the task at hand was to really illustrate to you how this might work. And then you see I put a little moon next to Earth there, and then put both around the sun, and I was sketching how they would go around the sun. And I'm quite sure you would be learning quite a bit from doing a 3D storyboard. Again, it doesn't have to be Tilt Brush. Use something that is for free and available to you, or you make that investment. You could also go pro and do Gravity Sketch, and there are some other tools out there as well. Anyway, we can discuss good tools. The 3D storyboarding is probably one that you would find very exciting. Personally, I think I get a lot out of the 360 storyboarding, just like because I find that template so cool but also challenging. And but every time I do it, I learn something, both about me and my limited sketching skills, and also then obviously about the project that I'm working on. And that is actually what matters. So this is going to be a fun exercise. You can blow it up a little bit by trying out these different kinds of storyboards, or keep it simple and just work on paper, but work through the flow and really figure out your new feature. Hey there, fellow honest track learners. I'm excited to welcome you to this next step on our path to creating this really cool XR project. Physical prototyping. I don't know, in every course I teach, I always get so excited when it comes to the physical prototyping stage. I mean, we were already quite physical when we were doing the storyboarding previously, but now we're really doing physical prototyping. So that includes paper prototyping, but it also goes beyond paper. And this is what I want you to learn and want you to practice and exercise. So I'll walk you through the steps of this exercise, and I'll come back at the end with a few ideas for how to make use of this activity. So let me walk you through the exercise, and I'll also share a few insights and tips along the way, since keep in mind I've actually been doing this myself in preparation for the MOOC, and so I spent quite some time prototyping, and I'll be happy to share a lot of these videos where it makes sense with you as well. So this is our task. Your task is to create a physical prototype of an Expeditions-like XR app. The same rules as before. I say Expeditions-like, it doesn't have to be Google Expeditions. I say XR, it can be VR, it can be AR, it doesn't have to be both. It can also be just 360. The key point of this activity is really to create a paper prototype of one of the key interactions, right? I mean, there's a lot of stuff you probably want a paper prototype, and that includes the content and all that, and I understand that. But we really want to focus our attention on the interactions. We really need to make more progress when it comes to that. But we're also going to do content. So we modeled 2 to 3 main 3D characters with clay. This will be fun. And we want to create a diorama with the 3D characters to define the story. Now, diorama doesn't have to be like the one that I'm going to show you. It can be just like in 3D on, it can still be on paper, but then think pop-out book. So it has to come out really into the physical world. We don't just want a paper prototype. We actually want to be more physical than that. And so bring some cardboard and yeah, do that. Record a video and narrate the interactions. That I think is a really important part. That brings your physical prototype to life and also allows you to share it with other learners. Optionally, you can create a 360 paper prototype to define the context. So 360 paper prototype would mean to use my template and follow some of the instructions. This makes a lot of sense, especially when you've done a 360 storyboard. Like to keep refining that storyboard and turn it into a 360 paper prototype, really wireframing it out and thinking about some of the transitions and interactions, and then actually start really playing with it, so moving the characters around on the grid. That is really cool. But as before, you don't have to do each and every type of physical prototype. You can just do a paper prototype, although I would like you to really play around with Play-Doh and create a diorama. The expected results from this activity, because these different types of prototypes also increase fidelity. I mean, you're still kind of low to medium fidelity, but you can increase fidelity just by changing the tools that they're using to create the XR prototype. So you will get a better sense of the problem, the context, and the story. And that's really important. These are the key ingredients that I introduced you to, and this really matters for XR, actually for any kind of user interface, but a story is particularly important in XR. We want to identify the key elements, so the environment, the 3D characters, and this also helps you drive requirements in terms of assets for digital prototyping and development later on. We really want to learn about the interactions. These physical prototypes will allow you to play around with the materials, try out different compositions, different scene compositions, different transitions, different animations, just by moving things around. All the things you would have to program digitally, you can now do in the physical world. And so that's so exciting. Get a feel for technical requirements and then also digital prototyping needs. I would say these are the expected results. This is why we do physical prototypes. When you share your physical prototype video, that's really cool. That would be a major accomplishment. What would be even better is you reflect upon that experience. Just you going through it in your mind again, reflecting. I usually have that activity with my students in the residential courses. We do the physical prototypes and then we write half a page, just thinking it through, like a little diary entry, thinking it through, what did I actually learn? And we critique both the method, like what was limited, what was hard to do. I was doing VR, but I was just using paper. And I was using a 360, but then how does 360 translate to AR? And that's something that is something that I've been thinking a lot about as part of my research. And it would be cool if you raised similar questions and maybe we can engage in some interesting discussions around it. Don't hate the 360 template. It will just require some time. There are easier tools out there. You don't have to jump right in. You can also do an immersive prototype, so keep in mind this is supposed to be physical, so don't jump into the digital tool yet. That is kind of not allowed. Ideally you would do with physical materials. I want you to get that experience. I think it's a pretty important one, and it allows you to think without all the technical constraints that you usually have to, well, face and solve and work around when you do digital prototyping or later on development. So that's why physical prototyping is so important. So as before, I'm doing the solar system, so I'll share a few of the things. I had obviously the knowledge from the design critique. I also had my storyboard. I did a standard storyboard. I was playing around with the app. I was going through the flow, and I was developing my own new idea on storyboard. I was actually then on paper and doing a normal storyboard, a traditional paper storyboard, and then I was doing this 360 storyboard, like sketching out. I got a few new ideas about light and shadows and what are the interactive objects. So that's something that I paid attention to. I previewed it, so I have all that experience, and that experience is important. We are taking that experience forward in our physical prototype here. And then I was doing a 3D storyboard using Tilt Brush. You can use other tools, I said, that's fine. In some sense, so this is an immersive authoring tool, so it's clearly digital, and we were doing that for the storyboarding. So now we're moving back to physical. Michael, is that really what you want? Yes. Yes, that's what I want. We're not moving back to physical. Don't think of it like in that way. Think of it in terms of a tool. The physical tools are the ones that we have around us in the physical world, so you're quite familiar with them. We can do so many things with paper, and that's something I want you to think about. So rather than you thinking, well, this is a step back from Tilt Brush, you think this is a step forward. It's paper. It's so much more versatile and flexible. Obviously, yeah, you won't have that stereoscopic view and this really, really key sense of a preview, but I'll also show you again how you can preview some of your prototypes using some of the tools that I have developed in my research, and you get versions of that. You get access to versions of that. So here is our landscape from the lecture on physical prototyping. I was talking about paper prototyping and 360 paper prototyping a lot, so that's like one thing that we're going to try. And then along the way, we're also going to do 3D models that we can then put in a diorama, and that will be cool as well. So let's get started with the paper prototype. I'll show you what I have done as I was working on the exercise. So here is me sketching out, well, screens first. So clearly the traditional 2D UI artist in me, that I am not, to be honest. But anyway, I was just like thinking this might be how you also may want to start on paper. And I was starting from the smartphone. It was an AR experience. I was sketching out a few of the screens, and this paper prototype was really just like the first step. All right, sketching out the different kinds of transitions. Now it goes beyond wireframes. I start coloring things. I'll actually turn it into screens. This is still relatively wireframey, but then I would actually cut it out. Could think of doing device stencils. I think what I did is actually I took screenshots of these and then just used my phone to play with the different transitions between these screens and states. That's something one can do, and it's very easy. So you don't have to be, so I say physical prototype, doesn't mean that you're not allowed to use anything digital. In fact, you should capture it at some stage. And so the paper is fine, but then using your phone as a tool is even better. Here, I was then actually highlighting the interactive areas. I was thinking, hey, maybe one can just like, the user can just click all these things that are kind of like blue, this highlighted blue, and then I was working on the moon, I think. And so also the rings on which the planets orbit around the sun, I was thinking would be cool if you could just click them and then go back or transition from Earth to sun and vice versa. So I'm going to show you my 360 paper prototype. Here's another time lapse, and so then I was, you probably thought, wow, Michael, this didn't look so bad. Why are you destroying it now? Well, you got to move on. So learn about the work by doing the next step. So I learned about the project, and I was like, okay, this is me just trying to make it rounder. Believe me, this sun, no matter what I tried, it never became really round. in any case, I was then using toothpicks, and I just needed more flexibility, putting up a little bit of a phone stand here, and then this is my plane where the AR objects will appear, and now I simulate these AR objects with physical properties on toothpicks, physical props on toothpicks, and then I can actually try out different transitions and how does the relationship between these planets work and what's the right scale. So I have like 2 sizes of the Earth. I have a third Earth somewhere. This is the moon that looks like a mushroom, one of my students said, and so she's not wrong. And yeah, I was just playing with this. Then I was moving to the 360 template. So you can also use the 360 template, but you don't have depth. So I was talking a lot about how you don't have depth and how you can simulate depth with different sized objects, and how you can do different kinds of well, orbiting and different kinds of transitions just using the template. The template is really quite cool, especially if you keep taking pictures and previewing things in AR or VR with the 2 versions of the capture tool that I'll share with you. Hope it works. Again, hope it works on your phones, capturing at different stages. And this is kind of like what I wanted to show you. I have a more detailed video that I'll share with you in full length if you want, where I really try it out. If you don't go through the whole step of creating this 360 storyboard, maybe by watching this video you can learn a little bit more about how this may work. So I'll share this video with you. I'm not going to comment on it now, but it will be available. And then I can preview. Right, that's the whole point. This template allows us, it's an accurate angular format, so we can actually convert it to spherical and then put it on a sphere in a 3D scene and then preview it in VR and also in AR. This implementation that I share with you right now at the stage when I was still developing the MOOC only has support for VR and 360. So 360 you can do, and then virtual reality. This is the 360 one. And at some stage I should be also showing how to do the virtual reality. You just click the virtual reality button and put it in the cardboard. And well, also here I'll share a longer video with you. I actually could cut all this together, and I think you'll learn quite a bit from just watching these videos as well. I wish more people used this template. I do think it helps me think a lot through environment and also then a little bit of the interactions, and you get such an interesting sense or actually so many surprises when it comes to scale. Then I wasn't really happy with how I was commenting on my objects that I was drawing. Like my son looked like a pizza or ice cream, and I felt like I wanted to eat it. So then I was like, hey, what else could I use? I could use a little bit higher fidelity, if you will, higher quality cutouts. So I got cutouts of Earth, Sun, and the Moon, and I was playing around with them at different kinds of resolutions. This is totally allowed. You can print out, you don't have to sketch everything. This template is very flexible. You can put things on it. You just have to pay attention to the scale and where you place things, but this is the point. So the 360 paper prototype can be really cool, and I'll play around with that as well. I'll share that video with you so you'll have the full overview. I was then also doing Play-Doh or some kind of clay modeling here, and yeah, I look like I'm making sandwiches or baking, but what I'm actually producing here is Earth. So yes, no, not what you're thinking. No, I'm not making Earth. No, I'm just doing my own little Earth here with clay. And I'm doing 2 different sizes of Earth because I know that I'll need them for close-ups. I need a bigger one, and then in relationship to the sun I really need to do a smaller one, but then I can't make it too small because how tiny is the moon going to be? And so that's the thing, right? In the physical world we have certain limitations when it comes to resolution and the scale and size of objects, and it is so interesting when you then learn about how these translate to VR and AR. The scale is probably the one thing that we never get right. Here I'm making a sandwich. No, it is actually a night version. It's supposed to be a night version of Earth. And then I was playing around with these texture sheets that I bought. Really cool. So these texture sheets actually give a pattern to the models, the props, and you will see in later videos they actually really stand out, especially when you use a digital camera. You can see every one of these little you know, little dents that I actually essentially made into the objects. I was playing around with toothpicks. The toothpicks is my way, but you can also use other ways to stabilize and mount the objects, and there's a number of different things you can do. Here's the sun that I'm making and shaping, and I'm trying to mix. I'm not sure I always got the colors right. At some stage I feel like I had to check. It actually doesn't have to look like the paper version. That was just me trying to match it because I knew I was going to produce videos for you. But really, I mean, it could look different. It should look like a sun, but it looks more like a pizza ball or something. And then once you have the clay, you can obviously really explore interesting things. So this is the video that I'm going to share with you again, because it is a major step here, and I think it nicely illustrates the advantages of using clay and physical prototyping and having these as well, the 3D models of your scenes. And I was playing around with different kinds of compositions and animations, because I could then really move these objects. I show a later portion at the end. I was playing around with different kinds of compositions. I remember I also put together like the Earth, the Sun, and the Moon. Yeah, I mean, this probably looks weird, but this is what you will look like when you then are supposed to take your video of your physical prototype. And so it's really important. I was just running it all the time, and I was using a little bit of basic video editing later on to cut it, so we didn't have to share. This is now bringing in all the objects, and I was going through. But the portion that I was looking for is this one, because it does really show nicely how you can then bring. The camera wasn't always playing nicely with me. It wasn't, the autofocus was a bit weird. But this depth of field effect is something that I fell in love with. And if I knew better how to do shaders in in 3D, then I would probably come up with that. I would probably implement a solution with the depth of field effect. In any case, I was then doing the diorama. So this is a 6-minute video that I'm happy to share with you. I really set it up quite nicely. I was proud to put this all together, and I will just go very briefly over what I did. So I was bringing back all my materials. This diorama is in some way the culmination of these initial physical prototyping steps. I actually did this last, and as I was doing the diorama, I was then also bringing in some of my tools again to have some AR previews. So that's what I'll show later. I'm just going to jump ahead a little bit. Here, for example, is what you see in the video is how I take some of my objects that were placed on paper, and how I can then actually preview that in AR. Now they are really floating above my little table here, and I thought that was so cool. So I'm going to share all this with you. I was also playing around with different backgrounds, and there is a part in the video that I find even more interesting. Now that is cool, but at the end I actually show this part is really cool, because I'll mix the physical and the digital here. So I have like two virtual copies in AR, and then I was bringing in the physical moon, and I was commenting on how obviously occlusion doesn't work, because the camera has a hard time seeing these objects that are so close to the camera, and it doesn't actually have body segmentation implemented AR core at this stage at least. And in any case, it would just see a toothpick and a little moon. But yeah, so you'll see me go through all these exercises and steps of the exercise. I actually had fun. I hope you have fun. I hope you do a subset of this, and you feel like you learned something. This is the physical part, and with a few tools to allow us to preview things in AR and VR. And then we're going to jump into the digital world after this. We're still using authoring tools, no programming yet, because that's what we're going to leave for the next course. But we are going to get to our final prototype that we can then actually also peer review. And yeah, we're going to talk about peer review as well.